All right, for objective 2, solve the differential equations by separation of variables. Some of them will be, most of them will be figuring out if this equation is a solution to this one. All right, so in number 3 it says show that this equation is a solution to this differential equation. Notice the differential equation has y in it, so we could plug this in, but it also has y prime, so we'll want to find y prime. Before we find y prime, it might be helpful to think of y as x minus 1 over x, or you might want to think about it with the negative exponent. But the derivative then, or y prime, would be 1 plus x to the negative second, or 1 plus 1 over x squared. All right. Now, doing some substitutions, there's an x in that equation. We'll leave that. In place of y prime, I'm going to put 1 plus 1 over x squared. And in place of y, I'm going to put x minus 1 over x equals 2x. And then we're using the distributive property. So multiplying this out would be x plus 1 over x. And then we still have plus x minus 1 over x equals 2x. These cancel, and so we get 2x equals 2x. And when we get to a true statement, we have shown that this equation is a solution to that differential equation. Okay. Number 4 says, which of the following functions are solutions to the differential equation? Here we have the second derivative, okay, and there could be more than one answer to this, so we do want to find the second derivative of these and then plug that in with the original and see what happens. Okay, so for A, to find the second derivative we need the first, so the derivative of the sine is the cosine, and then the derivative of the cosine is negative the sine. All right. So when I plug that in there, it would be negative the sine of x plus, and then I plug the sine in there, sine of x is supposed to equal the sine of x, and that is not true because this would be 0 equals the sine of x, which is not true. Okay. For B, the derivative of the cosine is negative the sine of x. The derivative of negative the sine of x is negative cosine of x. Again, plugging those in there, we'd have negative the cosine of x plus the cosine of x equals the sine of x. Again, that is not true. We'd get 0 equals the sine of x. So B is not a solution. C, y prime, we use the product rule here, would be the derivative of 1/2 x is 1/2, leave the sign alone, plus then leave the half x alone, and the derivative of the sine is the cosine of x. All right. Which means y double prime would be, let's see, constant multiple rule, so we leave the half alone, the derivative of the sine is the cosine of x, plus here we need the product rule again, the derivative of a half x is a half, leave the cosine alone, plus leave a half x alone, the derivative of the cosine is negative the sine of x, that's times negative the sine of x. So let's simplify y double prime first. These two half of a cosines make a whole cosine of x, and minus 1/2 x sine of x. And then again, plugging y double prime and y into here, we would have, let's see, cosine of x minus 1/2 x sine of x plus 1/2 x sine of x and that's supposed to equal the sine of x. So these cancel, that's good, but we end up with cosine of x equals sine of x, and that is not always true. So it's not C. So by process of elimination, it could be D, but again, this could be more than one answer or no answers. So we do want to run through the math for D, all right? And so the math for D, the calculus for D, is going to look like this. Let's see. Y prime, leave or take the derivative of negative 1/2 x, which is negative 1/2, leave the cosine alone, plus leave negative 1/2 x alone. The derivative of the cosine is negative the sine of x. I'm going to just clean that up before we differentiate it again. Two negatives make a positive. And then y double prime, constant multiple rule. This negative 1/2 stays. The derivative of the cosine is negative the sine of x. Plus product rule here, derivative of 1/2 x is 1/2. Leave the sine alone. Sorry about that. Plus leave 1/2 x alone. The derivative of the sine is the cosine of x. So again, combining these two negatives make a positive, and 1/2 sine of x and 1/2 sine of x make a whole sine of x. And we still have this 1/2 x cosine of x. So plugging that into our equation up here, plugging y prime and y in there, for D we would have sine of x plus 1/2 x cosine of x plus a negative 1/2 x cosine of x equals sine of x. Again, I'm plugging y prime in there and y in there, and the other side's done for me. And these two cancel each other out, and finally we have an answer. Sine of x does equal sine of x, so it is D.